Core Mathematics C12 Sample Assessment Material Part 3 Questions 10, 11, 12. Question 10. Sketching and Transformation. The first thing that we have to do is write down the coordinates of the point A. That means where does the curve y equals to x squared 9 minus twice x cut the x-axis. So question number A. At x-axis y equals to 0. Remember the equation is y equals to fx. So y means x squared 9 minus twice x. So therefore x squared 9 minus twice x equals to 0. So x squared means x times 9 minus twice x equals to 0. Therefore one value would be x equals to 0, or another value would be x equals to 0, or it would be x equals to, if you write 9 minus twice x equals to 0, it would be x equals to 9 by 2. So we have to write down the coordinates of the point A. Answer: A has coordinates 9 by 2, 0. Question B1. We have to do a transformation. Now this particular transformation is a shifting towards the left by 3 units. So let's sketch. So we have x-axis, y-axis, label it properly, give the origin. Now we know if it shifts by 3 units, 0 would be at minus 3. So this would be minus 3. And 3, when x is 3, this would be at 0. So the picture would be, and A, which is 9 by 2, remember 9 by 2 is 4.5. If 4.5 shifts by 3 unit, it would be 1.5, meaning 3 by 2. So this point would be 0, 27. X would be 0, y would be the same. And this would be minus 3, 0. Question 2. We have a transformation which is f thrice x. That means we have to divide x with 3. This is stretching. So x-axis, y-axis, origin. So let's draw this as it is. So it would be like this at 0, and it would be like this. Now the y coordinate would be the same, only the x coordinate would be divided by 3. So if x is 3, 3 divided by 3 is 1. So this coordinate has 127. And the coordinate of A, let me write A over here, was 9 by 2. So 9 by 2 divided by 3 is 3 by 2. Question C. The curve with that equation, now if we do plus k, where k is a constant, has a maximum point 310. Now think about this. If the curve has turning point maximum point 327, now they're saying it has 310. That means it is moving down by 17 units. 27 minus 17 is 10. So the transformation is going to be, question number C, y equals to fx minus 17. This is a translation. So what is the value of k? The value of k has to be negative. K equals to minus 17. Question 11. Curve sum. In question A, we have to find the point of intersection between the curve and the line. So we have to solve this by substitution. Y equals to minus x squared plus twice x plus 24, that is equation 1. Y equals to x plus 4, this is equation 2. So if you write y equals to y, it would be x plus 4 equals to minus x squared plus twice x plus 24. we can write, if we bring the minus x squared to this side, it would be x squared minus x minus 20 equals to 0. So 5 fours are 20. So x squared minus 5x plus 4x minus 20 equals to 0. Remember, it has to be minus x. So 4x minus 5x is minus x. If we take x common, it would be x minus 5. If we take 4 common, it would be x minus 5. So this is x minus 5 and x plus 4 equals to 0. Therefore, x equals to 5 or x equals to minus 4. Remember, we have to find the coordinates of the points A and B. So we found two coordinates, but they're all x coordinate. We have to find the y coordinate. At A, we know x has to be negative at A. So x equals to minus 4. Let's put it here in the easier equation. Y equals to x plus 4. Minus 4 plus 4. And that would be 0. So A has coordinates minus 4, 0. At B, x equals to 5. So we have y equals to, again we can put over here, 5 plus 4, that is 9. So B has coordinates 5, 9. Now in question number B, we have to find the area of the shaded region, and for that we have to use definite integral. Now remember, the area is bounded by a curve and a line, what we call type 2. And in order to find area like that, we have to subtract. First of all, let's find the limit from A to B, where they cover the entire finite region starting from A to B. The limit is minus 4 to 5. Now we have to subtract the curve and the line. So since we have the curve on top, so minus x squared plus twice x plus 24. Now subtract that with the line, which is x plus 4. So x plus 4 dx. Now let's simplify first. Minus 4 to 5 minus x squared. Now 2x minus x is going to be plus x. 24 minus 4 is going to be plus 20 dx. So we have minus x cubed by 3 plus x squared by 2 plus 20x, and the limit is minus 4 to 5. We have to put 5 first. So minus 5 cubed by 3 plus 5 squared by 2 plus 20 into 5. Subtract this with minus 4 minus minus 4 cubed by 3 plus minus 4 squared by 2 plus 20 into minus 4. Let's calculate, but before using the calculator, let's see how much we can do by ourselves. So minus 5 cubed is 125, so this is 125 by 3, plus 5 squared is 25, 25 by 2, plus 20 into 5 is 100, minus, now this is minus 4 cubed is minus 64, and there's a minus in front, it will be plus 64. So this would be 64 by 3 plus, now 4 square is 16. 16 by 2 is 8 minus 20 into 4 is 80. So now we can start using the calculator. So 25 by 2 plus 100 minus 64 by 3 minus 8 plus 80. So we have minus 125 by 3 plus 25 by 2 then we have plus 100, we have minus 64 by 3 minus 8 plus 80, and it is 121.5. In fraction it would be 243 by 2. This is question number 12, and it deals with circles and coordinate geometry. Question number A, we have to find the equation of the circle. Now if we know the center AB, and the radius r, then the equation of the circle is x minus a whole squared plus y minus b whole squared equals to r squared. So we can see this question as we have a circle and the center is A and we have a point B over here. So AB is the radius. So the point B is 10, 7 and the point A is 2, 1. Find an equation for the circle C. So first of all, we need to know the center. So the center is 2, 1. Now we need the radius. Now we know AB. The line from the center to the circumference is the radius. So AB is the radius. So let's find the length of AB. Square root of difference of x is 10 minus 2 whole squared plus difference of y, which is 7 minus 1 whole squared. This would be square root of 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36. So this is 100, this is 10. So the equation of the circle would be x minus center x coordinate is 2, x minus 2 whole squared plus y minus 1 whole squared equals to 10 squared. That means x minus 2 whole squared plus y minus 1 whole squared equals to 100. You don't have to break down these brackets. Question B. We know that there is a line L1 that is tangent to the circle at the point B. So we are talking about a line like this. So it is a tangent to the circle at the point B. Now we know one thing, the tangent and radius makes 90 degree. So the first thing we need for finding the equation of a line is the gradient. So gradient of AB, which is the radius, is change of y, which is 7 minus 1 divided by change of x, which is 10 minus 2, which is 6 by 8. 2 3s are 2 4s are 3 by 4. Now since the tangent is perpendicular to the radius, so we can write gradient of tangent would be minus 1 by m2. So minus 1 by 3 by 4, which is minus 4 by 3. Now let's find the equation of tangent. Now the equation of the tangent, we can find it using the point slope form. So the point through which the line passes is 10, 7. So y minus y1, the m, the gradient is 4 by minus 4 by 3, x minus x1 is 10. We need integer coefficient, so let's cross multiply. 3y minus 21 equals to minus 4x plus 40. It turns out to be 3y plus 4x equals to 61. Question number C. The line L2 is parallel to L1, meaning the tangent, and passes through the midpoint of AB. Given that L2 intersects the circle C at the points P and Q, find the length of PQ. Now, this might seem very difficult, but actually it is not. It is basic geometry. If you have a diagram, the whole thing would be clear, and all we have to do is basic geometry, Pythagorean theorem. So let's draw this all over again. Question number C. So we have a circle and we have this line over here, which is the tangent line. So we have this line over here and we know that the center of the circle is A, and we know the point at which the tangent is drawn is B. So let's join this AB. Now we have another line L2 which passes through the midpoint of AB and it meets the circle at 2 points P and Q. What we have to find right now is the length of PQ. Now we already know the radius of this circle from question A, which is 10. So this is 10 and this is 10. We also know that when we have the radius and a chord like this, they are meeting at 90 degree and this is bisected. This is the circle theorem. So let's redraw this as a triangle. So let me call this portion X. So if I redraw this like this is A, this is Q, and this is X. So this is 10 and we know that the midpoint of AB, if the length of AB is 10 and L2 passes to the midpoint of AB, that means this has to be 5. Half of AB is 5. AX is half of AB. So this and this is also equal. Now using Pythagorean theorem in triangle AXQ, we can find the length of QX. So it would be 10 square equals to 5 square plus QX whole squared. It would be 100 minus 25 equals to QX whole squared. So that would be 75 equals to QX whole squared. Therefore, QX equals to square root of 75. Length cannot be negative. So the entire length of PQ would be double of QX. So it would be twice square root of 75. Now we have to give the answer in the simplest surd form. Let's break this down. So 75, if we break this, it turns out to be 3 2s are 6, 3 5s are 15, 5 5s are 25. So we can write 75 as 5 squared into 3. If 5 squared comes outside the square root, it would be 5. And we have 2 outside. So 2 times 5 square root of 3, it would be 10 square root of 3. That's PQ.